learn like a pro.
All right, let's get right into it. Today, we're doing a super focused exam review on a couple of really key topics in organic chemistry. That's right, carboxylic acids and esters.
So you've got a chemistry exam coming up, right? Maybe you're cramming a little. Don't worry, you are in exactly the right place. We're going to break down everything you absolutely need to know super fast and super clear. The goal? To have you walk into that test feeling totally confident.
Okay, here's our game plan for the next few minutes. We'll kick things off with the absolute essentials on carboxylic acids. Then we'll hit their classic reactions. After that, it's all about making those awesome-smelling esters. We'll even see how you can turn an alcohol into an acid. And to wrap it all up, a quick quiz to make sure it all sticks. Sound good? Let's do this.
All right, Section 1, Carboxylic Acid Essentials. First things first, we've got to get the fundamentals down. Thinking about these acids as a homologous series is super important because it's the key to predicting how they're going to behave.
Okay, so check out this table. It lays out the first 4 members of the carboxylic acid family. See what's happening with the boiling points? Take a look. Yep, they're going up. As the molecule gets bigger, as that carbon chain gets longer, the boiling point just climbs and climbs. And why is that? Well, it's because those bigger molecules have stronger forces holding them together. So you need more heat, more energy to break them apart. This is a classic trend, definitely one to lock away for the exam.
Now, trying to remember those names in the right order can be a pain, right? Well, I've got a super simple trick for you. Just remember this sentence. My excellent professor bakes. See? Methanoic, ethanoic, propanoic, butanoic. It's a really easy way to snag some points.
So you're going to hear the term weak acid a lot when talking about these. But what does that actually mean? It's not about strength like in the gym. It just means that when you put them in water, they don't fully break apart. Only some of the molecules release their hydrogen ions. See that equation for a thionaic acid? Those double arrows tell you it's a two-way street. It's a reversible reaction. So it kind of settles into this balanced state called equilibrium.
Okay, moving on to Section 2, the reactions. Now you're going to want to pay really close attention here, because I can pretty much guarantee you'll see these kinds of equations on your exam.
So, there are 3 main reactions that you absolutely have to know. First, acid plus a metal gives you a salt and hydrogen gas. Second, acid plus a carbonate. This one's fun. You get a salt, water, and carbon dioxide. And the big giveaway here, you'll actually see it happen. It's going to fizz and bubble as that CO2 gas escapes. And third, the classic. Acid plus a base, that's just a simple neutralization reaction that gives you a salt and water.
Let's look at a real example to make this stick. Here we've got solid potassium reacting with ethanoic acid and water. So what happens? You get potassium ethanoate, that's our salt, and hydrogen gas. It's actually pretty simple if you look at the molecules. The potassium atom basically just comes in and boots out the hydrogen atom at the very end of the acid.
All right, Section 3. This is a really cool one, making esters. It's this magical process called condensation or esterification. And believe it or not, it's how we get so many of the smells and flavors that we know and love.
So why are we even talking about esters? Well, because they smell amazing. Seriously, these are the molecules that give us so many sweet smells and flavors. You know, perfumes, the artificial flavoring in candy that tastes like banana or pineapple. Yep, that's all esters. They're a massive deal in the food and perfume industries.
Okay, so how do you actually make an ester? The reaction is called condensation. It might sound fancy, but I promise it's straightforward. You start with 2 things, a carboxylic acid and an alcohol. Think of it like building with Legos. The acid piece gives up its little OH part. The alcohol piece gives up just the H from its OH part. What do you get when you put OH and H together? H2O, water. So a water molecule pops out, and the 2 big pieces that are left over, they snap together to make the ester. It's like a molecular team-up. And this diagram shows you exactly what I'm talking about. Here you can see ethanoic acid and propanol getting together. See how the minus OH from the acid and the minus H from the alcohol are highlighted? They're about to pop off and form that water molecule. Now, something really important to remember. This reaction is kind of slow on its own, so we need a catalyst to speed things up, usually concentrated sulfuric acid. And a quick safety note, like the caption says, concentrated sulfuric acid is serious stuff. You have to handle it with a lot of care.
So how do you name these things? It's actually a super easy 2-part recipe. First, you look at the alcohol part. Propanol becomes propyl. You just change the anol to ol. Then you look at the acid part. Ethanoic acid becomes ethanoate. You swap oic acid for OAte.
Stick them together, and what do you have? Propyl ethanoate. See? Simple.
Okay, on to section 4. So we just saw how acids and alcohols can team up to make esters. But did you know you can go the other way? Well, sort of. You can actually make a carboxylic acid starting from an alcohol. The process is called oxidation.
And here's a little real-world chemistry puzzle for you. Have you ever left a bottle of wine open for a couple of days and then taken a sip? It tastes sour, right? Almost like vinegar. Ever wonder why? Well, the answer is oxidation.
Yeah, that sour taste is literally ethanoic acid, which is the main chemical in vinegar. What happens is the ethanol, that's the alcohol in the wine, reacts with oxygen from the air. Bacteria often help this along, and boom, the ethanol oxidizes and turns into ethanoic acid. This diagram here just shows you how you would do this on purpose in a lab, by heating the ethanol with something called an oxidizing agent.
Okay, listen up, because this is a huge exam tip. If you use a specific oxidizing agent, acidified potassium manganate 7, you get this amazing, really obvious color change. It starts out bright purple, and by the end of the reaction, it turns completely colorless. If an exam question asks you what you would observe, this is the golden ticket answer: purple to colorless. Got it?
All right, we've covered a ton of ground in just a few minutes. You've been absorbing all this info, so let's do a super quick quiz to see what stuck.
Pop quiz number 1. What's the name of that special functional group, the bit that's in all carboxylic acids and makes them what they are?
And the answer is the carboxyl group. That's spelled COOH. This little group is the hero of our story today. It's responsible for all the chemistry we've been looking at. Okay, question number 2. Let's rewind a bit to those 3 key reactions. What are the products you always get when a carboxylic acid reacts with a metal carbonate?
The answer is you get 3 things: a carboxylate salt, water, and of course, carbon dioxide gas. And remember, that CO2 is what gives you all that telltale fizzing.
And for a final thought to leave you with, you now know the recipe for making esters. So here's a fun one. Can you guess which acid and which alcohol chemists use to make the artificial flavor of bananas? I'll give you a hint. It's ethanoic acid and an alcohol called pentanol. Together, they make pentyl ethanoate. Pretty cool, huh? Think about that next time you eat a banana candy. Okay, that's it. Good luck on your exam. You're gonna do great. You've got this.